Hello friends, welcome back to Coding Search, the next era of learning. Today in this video we will look at the why we need data types and we will understand different categorization of the data types on different levels. We will also look at the different types of primary data types and the range of the data they can store. And at last we will also understand and learn how we can code our own secondary data type. So friends, before moving ahead, I would like to request you to please subscribe this channel if you have not yet subscribed. So why we need data types in C? Assume a situation that you have to write a program for any company where you have to store the data of employees. Therefore, you have to deal with the different types of data like integer, alphabets, and decimal points or the floating point numbers. That's why there are different types of data in C. So what are the data types in C? Friends, data type is an attributes of data which tells the compiler which type of data a variable will hold and also tells that how much memory will be allocated to that data type. For example, data type may be integer, float, character, boolean, etc. In C, the data type may be broadly divided into two groups, that is primary data type and secondary data type. Primary data type is further divided into numeric data type and alphanumeric data type, whereas numeric data type may be further divided into integer data type and the decimal data type. The decimal data type is also known as the floating point data type, and in alphanumeric data type there is a data type named character data type or char data type. This primary data type or the primitive data type is available in the C library, whereas the secondary data type that is further divided into user defined data type and derived data type. This is also called non-primitive or reference data type. So friends, primary data types are the most basic data type and all the other data types are derived from the primary data type or basic data type. Primary data types are integer or you can say int, next character or char, third one is floating point or float, double floating point or double, and last but not least that is void. One more thing you should note that we can modify all this data type by preceding the keywords short and long or signed and unsigned. Let us see what are these shorts and long and also signed and unsigned. These are used to define the amount of memory space that the compiler will allocate to the variable or data type. For example, short int, for which the compiler allocates typically 2 bytes, and for long int the compiler allocates 4 bytes. Signed and unsigned specifier. This also deals with memory allocation but in different way. Like in case of signed int, it takes into account both negative as well as positive numbers, whereas unsigned int deals with only the positive numbers. You might be knowing that 1 byte is equal to the 8 bits and 2 byte is equal to the 16 bits. So you can note down a formula that is 2 to the power n minus 1 that shows the number that can be stored in n bits memory allocation. Friends, this video is going to be a bit longer today because I have to discuss the range of different data types in which I am going to give you very vital information that is going to help you in your programming field. So please keep watching. Friends, here in this table you can see the different types of data and the size allocated by the compiler and the format specifier used for these data types. Like for int, memory allocation is typically 2 bytes for 32-bit processor, and for 64-bit processor the memory allocation is usually 4 bytes, whereas for char type the memory allocation is done only 1 byte, and for float 4 byte, double 8 byte, and with short int the memory allocation is only 2 bytes, and unsigned int the memory allocation is at least 2 byte but usually it is 4 byte. The format specifier for this data type, for int we usually use %d or you can also use %i. For char data type we use %c, and for float we use %f, whereas for double we use %lf. For the short int we use the format specifier %hd, and for unsigned int we use the %u as format specifier. And for long int, the memory allocation is at least 4 bytes, and usually for long int, the memory allocation is 8 bytes, and we use the format specifier %ld. And for long int, the memory allocation is 8 bytes, and the format specifier we use is %lld. And for unsigned long int, the memory allocation is at least 4 bytes, and we use the format specifier %lu. Similarly, for unsigned long int, the memory allocation is at least 8 bytes, and we use the format specifier that is %llu. And unsigned char memory allocation is 1 byte, and the format specifier is %c. And at last, long double. For long double, the memory allocation is at least 10 byte, and usually it is allocated 12 or 16 byte, and we write the format specifier %LF. Now the void data type. It is a special type of data known as empty data type that is used to state that a given variable does not have any type. This is mainly used in defining the function where we do not want to return any value. Now the secondary data type. Secondary data types are formed by combining two or more primary data types in C language. They are mainly of two types. One is user-defined data types and another is derived data types. Let us see user-defined data type. These data types are defined by the user as per their convenience or the requirement, and the user-defined data types are structure, union, type def, and enum. A structure is a user-defined data type where we can collect the similar or different data type at a same place, and a structure is defined by using the keyword struct, like you can see over here, the struct student, where we define char name 50, int roll number, float, marks. So here you can see that this structure student holds different type of data like name, that is of char type, roll number, that is of int type, and marks, that is of float type. And union is also a user-defined data type that is used to collect different types of data at same place, and it is declared using the union keyword like union emp, float f, and char x. Here you can see that f and x are of different data type. F is of float type and x is of char type, and type def is used to change the name of the primitive data type. For example, we can write type def int space integer and integer x comma y. Here note that this integer has been assigned a name for int, or you can say that data type name int has been changed as integer, and now you can declare different int data type using the integer name like integer x comma y. And at last, enum is a set of element that is assigned a numeral value. Here you can see the enum months, and within curly braces Jan, Feb, and March. Here Jan is assigned the value 0, Feb is assigned the value 1, and this March is assigned the value 2. Now the derived data type. Derived data types are data types which are formed by combining one or more primitive data types or the basic data type in C. For example, array, string, pointer, and function. Friends, array is a collection of similar data type in a contiguous memory location. For example, if I declare int array 6, then the compiler will allocate 6 memory allocation for int type, and the index of this 6 memory location will start from 0. And a string in C is an array of characters, and the difference between the normal character array and a string is that a string contains null value, that is \0 at the end, indicating that it is the end of the string, while a simple character array does not need to have this. The null character is a special character which is known as the null character, and it is used to indicate the termination of a string. And the pointer is a special type of data type that stores the address of another variable. And function in C or in any programming language refers to a set of instructions that when executed in a given order performs a specific task. So thank you very much for watching. Have a nice time.